Here we're being asked to, again, differentiate, which means find the derivative of this given equation right here. And then, like they're commonly saying, they say with respect to x, which is really just telling us the variable that we care about. So as we look at this problem, we see first and foremost, we've got a square root in it. As soon as you see a square root in a problem, you got to say to yourself, I need to do a rewrite on that. One of the first things you do before you go rushing in to take a derivative is always look for any sort of algebraic rewrites. And this is one of them right here. So whenever you have a root in a problem, you need to do a rewrite on that and turn it into a power. And so the rewrite on this says x to some power inside a root. You would rewrite that as x to the power divided by the root. The confusing thing to a lot of people on this is how to deal with the inside here. So really what's going on in this situation is all of that stuff right there is to the first power. And then because this is a square root, we've got an unwritten 2 for our root. So when we come through to rewrite this, what we're really going to get is all that stuff on the inside, 7x cubed minus 45x squared plus 35x over 5x to the fourth plus 3x squared, and all of that to the power of 1 over the root of 2. So this was just a rewrite only to get from that stage to the next. Anytime we see a root in a problem, we need to do a rewrite. Now what we have to determine is we can see we got a lot happening here. There's definitely some parentheses with stuff raised to a power. We got things being divided. And we always have to determine what is our primary rule. What's the main rule that we need to be following? And so what I always tell my students is to sort of, one, listen to what you were saying when you were writing that down. If you remember, we read that, reading through that, you'd say 7x cubed minus 45x squared plus 35x over 5x to the fourth plus 3x squared. All of that to the 1/2 power. And so right there, that should kind of tell you that putting all that inside the parentheses is leaning us towards probably a chain rule as our primary rule. But what I always tell people is think about the shape. Sort of squint your eyes and look at that problem. And if what you look at when you're squinting your eyes is you see two chunks being multiplied, then that's when you'd be looking at a product rule as your primary rule. If you squint and what you see first and foremost is two chunks being divided, then in that situation you would want to follow the quotient rule as your primary rule. And then if you see a bunch of stuff kind of raised to a power out here, if that's what you see, or if you see one of your special cases, one of those derivatives you just have to have memorized, then in this scenario you're looking at a chain rule setup. And so if we squint our eyes, or if we listen to how we said raised all that to the 1/2 power, we should be saying to ourselves, this looks like a chain rule setup. I've got a bunch of stuff inside of parentheses raised to a power. That's just a classic chain rule setup. So that is my primary rule. So I write down what the chain rule is. I say, okay, my chain rule saying goes D in times D out. You might have your own little saying, but I like something simple that I can remember and use over and over again. So what that's saying is I want to take the derivative of whatever's inside those parentheses and multiply it by the derivative of what's on the outside here. So looking at this specific problem, we could say to ourselves, what is inside that root, what's inside that 1/2 power, that is my inside piece. So now that I know that, I take that chunk and I pull it out. This is how we turn a big, huge, nasty problem into a bunch of bite-sized little math problems that we can easily do. So looking at my in now and saying to myself, okay, I need to go find the dn, the derivative of that. Well, if I had to take the derivative of that, what rule would I need to take the derivative of that? And so again, squint your eyes and see what you can see. To me, when I squint my eyes, I look at it and I say I've got something divided by something. So to take the derivative of this piece, we are going to need to apply the quotient rule. Again, whatever saying you have for the quotient rule, as long as you've got one that you have memorized and can recite by heart. Mine goes low, D high, minus high, D low, and then all of that is over the low squared. So I label the top piece the high piece, the bottom piece the low piece, and again, I break this thing out into bite-sized little chunks to get to where I need to go. So the high piece is 7x cubed minus 45x squared plus 3x. The low piece is 5x to the fourth plus 3x squared. Now I need to go find, to do my quotient rule, I need my d high and I need my d low, the derivatives of those pieces. So again, I look at those little bite-sized math problems and I say, okay, to take the derivative of the high piece, what do I need to do? Well, that's just a straight up power rule. You know, I always say everything flows through the power rule, right? So you're almost always going to end up doing a power rule on a problem. The power rule saying that I use just goes bring the power down and then subtract 1 from the power. So following that rule here, I bring my 3 down. 3 times 7 gets me 21x. Subtract 1 from the power gets me x squared. I bring my 2 down. 2 times negative 45 is negative 90x. Subtract 1 from the power gets us x to the first. We got an unwritten 1 on that x, so I bring the 1 down. 1 times 3 gets me 3, and then subtracting 1 from the power gets me x to the 0. And as we've probably talked about before, anything to the 0 power is always 1, so 1 times 3. Then we go over to the low side and we play the exact same game. I say, looking at this low chunk, how do I take the derivative of that? Well, again, that's just a bunch of stuff being added and subtracted, and so that again is just going to be our power rule. So we bring the power down. We get 4 times 5 gets us 20x. Subtract 1 from the power gets us x to the third. Bring the 2 down. 2 times 3 gets us 6x. Subtract 1 from the power gets us x to the first. And so now we have all the pieces that we need to put together our secondary rule here, which was the quotient rule. So to get our d in, we needed to follow the quotient rule. So now we'll do that. So the quotient rule says first go grab the low piece. So I go grab the low piece. So 5x to the fourth plus 3x squared. Then it wants me to multiply that by the d high, the derivative of the high. So I go grab that chunk. 21x squared minus 90x plus 3. And then minus, so put the minus in there, and it says go grab the high piece. So now I go grab that high piece. So 7x cubed minus 45x squared plus 3x. Multiply that by the d low, the derivative of the low. So 20x cubed plus 6x. And then all of that is over the low squared. So put a big division bar, wrap a set of parentheses around the low piece, whatever that might be. 5x to the fourth plus 3x squared here. And then all of that stuff squared. So there's our d in. And then to find our d out, reminding ourselves that we're running really through a chain rule here. To go find our d out, the outside piece here is this big power rule. It's all this stuff inside there raised to the 1/2 power. All the stuff inside is just going to stay the same. We're not going to mess with it. It's just going to come along for the ride. We took the derivative of that already. So we've already handled the derivative of that inside stuff. So it's coming along for the ride. And then on the out here, to find the d out, this is really just a giant power rule. We're going to bring that 1/2 down in front. We're going to leave alone all the junk we already took the derivative of, and then subtract 1 from the power. 1/2 minus 1 gets us negative 1/2. And again, all that junk that's inside there stays the same. It's just coming along for the ride as we do this process, because we already found that derivative. So there we have it. We now have our d in and our d out. That was what we needed to find our primary derivative, which was the chain rule. So we use our d in, we use our d out, and we give them the final answer for the derivative. So f prime of x is going to equal d in, the derivative of the inside, which is all that stuff right there. So 5x to the fourth plus 3x squared, 21x squared minus 90x plus 3, all that minus 7x cubed minus 45x squared plus 3x times 20x to the third plus 6x. All of that is over the low squared, all over 5x to the fourth plus 3x squared, and that whole thing squared. So that's our d in, and now we're just going to multiply that by the d out. So that'll be 1/2 parentheses, leave all that stuff alone. then over 5x to the fourth plus 3x squared. And then all of that, get this stuff out of our way here. We're done with the power rule now. All of that is to the negative 1/2 power. And that's your derivative. You're done. Walk away. Remember, when you're doing these, it's about identifying the primary rule and then breaking it into bite-sized little math problems. And at each level, you just say to yourself, how do I take the derivative of that little piece? And you use your identifiers to identify what that rule is, apply it, and keep going. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.